everyone, welcome to my channel. Today it's time for the second part of this series about building a MIKE21 SW numerical model. Today I'm going to explain you how to digitize the bathymetry, which you referenced in the video number 1 of this series. If you haven't watched it and you want to be able to follow this video, please click on the link below. Digitizing the bathymetry of an Admiralty chart means extracting the bathymetry levels from it in form of a file that will contain for each point recorded its coordinates x, y, and z. You will be able to combine the information obtained this way with the information obtained from the bathymetric survey that you have to perform of the area inshore. As I said in the first part of this video series, if you already have bathymetric information of the area to be covered by the model, you can skip this video, but be sure that you have bathymetric data from the offshore area. If not, just use this method to complete the information missing from the bathymetric survey. So let's begin digitizing the Admiralty chart. I have it here, the MIKE0, this is the first screen that appears. I'm gonna be working with a 2009 version. There is a 2014 and a 2016 that DHI has just released. The method doesn't change, at least for digitizing the bathymetry, so I'm gonna work with the 2009 version. If you have downloaded the 2014 or 2016 version, you can do the same. You will be able to do the same. So I'm gonna open a new file. I'm gonna select bathymetries. It appears here under the menu MIKE0, bathymetries. Okay. So first of all, what Mike asks us is the projection, the map projection that we're gonna be using. As you remember from the first video, we were working in an area around the zone 29, the northern hemisphere, and now, well, if you should modify this according to your needs. Now what Mike asks us is the geographical position of origin. What means is Mike is asking us this coordinate here, this lower left corner, that one. So if you select this one, you just have to put the coordinates of that corner. They are -8 and the latitude is 56. Now you have to define the size of the area that you're gonna be working in. So as you remember, I was using an Excel spreadsheet to calculate that the distance, the width, and the height of the Admiralty chart. Basically, it's asking us for this dimension and this dimension. So if you wanna know how I have obtained or created this spreadsheet, just go to video 1 and you will have it there. So this is telling me that the width of the Admiralty chart is 101,000 meters. I'm gonna define it here as 105,000 just to give me some margin, and the height as 7,000 meters. So I'm gonna define it as 75,000, just a little bit more to avoid any problems. So okay, as you can see here, what Mike show us, it's showing us two different grids. One is this blue dashed line perpendicular to those edges, and then there is this black grid. This black grid is the map projection WGS 84 for the zone 29. So of course, as it's trying to adjust a plane to a to a sphere that will be the Earth. Well, it's not a sphere, but let's keep it simple. It's not perpendicular to the edges of the screen. And now you'll see what I was explaining in the first video when I was georeferencing the Admiralty chart, that at the end of the process the Admiralty chart adopted this shape. Why the Admiralty chart adopted that shape? So I'm gonna load that image, the georeferenced image, as background. I'm going to work area, background management, import. I have to select the PMP map, and I'm going to select the R file. This is rectified, so this is the georeferenced one. And I click OK, and nothing has happened. Why? Because Mike sometimes it's a little bit dodgy and wants us to actually say that we want to show that image. As you can see, that the format shape that the Admiralty chart adopted while georeferencing it now makes sense, because as you can see here, this is the upper edge of the Admiralty chart, and now it's parallel to this grid line that defines the map projection. So at this stage, now we can tell that the image is correctly georeferenced, because the edges of the Admiralty chart, the georeferenced one, are parallel to those lines that define the map projection. Okay, so what we want to do is, say all those lines are the contour lines that define the seabed, the bathymetry of the area. In this particular area, the bathymetry here is quite complex because it changes quite a lot. So let's say that to digitize the bathymetry of this Admiralty chart, we will spend around, let's say, 2-3 hours to do so. 2-3 hours if you do it as I'm gonna do it, and I'm not gonna go really into lots of detail because it won't make sense for the sake of this video. But I recommend you to, well, if the project worth it, to create a really detailed bathymetry. Of course, it will be a lot more important to get detail of the area close to the shore, in shallow waters, rather than in offshore, because of the wave transformation processes are a lot more affected by the seabed when the waves get closer to the shore in shallow areas rather than in offshore areas. So if you define the bathymetry around here, well, roughly, you define it roughly, it won't affect very much to the results of the model. But in the areas closer to the shore, you should pay more attention to all of this. So what we're gonna do first is to define what are gonna be our land boundaries and what are gonna be the water boundaries. This is needed for Mike to understand what is land and what is water. So we're gonna go to this icon. It says add land water polygons, and this is pretty easy, and maybe you're gonna be a little bit surprised how is it done, but it's just what you have to do is just follow the contour of the island or of your land boundary. In this case, is this island here. So I'm doing it pretty fast again because well, it's just for the video, and I don't want to spend just lots of time just doing this, but just do it more detail when you do it for your project. So I've just defined that one. There is another piece of island here. Done. We can even say define that this is an island. Okay, so to save some time, let's say that you want to obtain the wave conditions here. It won't make lots of sense to spend time defining these areas, for instance, because the waves coming from here or here that appear to be the, well, they have a big fetch. It is the Atlantic, so they're gonna affect a lot more to the area here rather than the waves that are coming from here. So it just now depends on the amount of time that you have to do this operation. So if you don't have lots of time, you can, well, you have to analyze your area conditions and decide if it's worth it to define everything that appears on the Admiralty chart. Well, I'm not gonna do it, but you should. Or maybe to model those little islands here. You know, if you're gonna get the, or you're interested on the wave conditions here, probably those islands are not really interesting. Anyway, after you finish defining all the land boundaries, we're gonna start defining or digitizing the bathymetry. The process is pretty similar. You just have to work by areas. So let's say that I'm gonna start from this edge. We're gonna go to work area, set current contour level. This window, you should have it open because this is what is gonna be used to define where are the contour levels that you're gonna be working in or digitizing. So we're gonna define this contour line. This is the minus 100 meters. So we're gonna create a new one, define where is the level, and now you have two options here. You can go to this button here that says add contours, click on it, and what it's gonna do is to create like a continuous line of points. I'm just following this line with a mouse, trying to do my best. Again, I'm doing it pretty fast, but you should do it more accurately. So this is one way. If you're pretty skilled with a mouse, this won't represent you any challenge to do it, but maybe it's a little bit just to keep the mouse going around those edges. It could be a little bit tricky sometimes. Let's say that you want to define also, this is the minus 15, so I'll create a new contour level, minus 50, and I will just follow this. You can ask the kids to do this. No, don't do it. They will get bored quickly. So again, so now it will be a matter of switching between the contour lines that you have created to define all those contours. The other way to do this, to define the bathymetry, is this one, is add points. If you want to save some time, maybe this is going to be a better option. And this is define a limited amount of points that will define your contour line. So as you can see, this is an easier method, and depending on the accuracy that you need, maybe it will worth it. So this is pretty easy. Now every time you spot a different contour line, you define a couple of points, and that will be it. As you can see, well, the difference is having a limited number of points to define the contour lines, or a little bit more detailed definition of those contour lines. So that's it. Now the only thing that you need to do is to cover the whole area. As I said, doing it point by point with this, I kind of rather prefer to define point by point rather than this kind of continuous contour lines because it's easier, and if you have made a mistake, it's easy to rectify it. So if you have made a mistake while defining those points, what you can do is to move those points. See, you're just clicking on the point, and you can move it around to fit the bathymetry if you think that this is not accurate enough. This other little green hand here is just to select points. If you need to delete it, just select the point, click on delete, or press the delete button, and it will delete the line. And that's it. This is digitizing the Admiralty chart. Once you have finished with everything, you should go to export. And Mike, well, you define here the name. I have already created a couple of bathymetries, and Mike will create two files: the land bathy file and the water bathy file. Both of them contain a file with every point that you have defined, that you have digitized, with the X, Y, and Z coordinates that we will use in the next video. So I have worked a little bit on this Admiralty chart. This is what it will look like once you have defined half of the Admiralty chart. And as you can see here, I paid a lot more attention to this area because it's getting in shallower areas. So once I finish digitizing the rest of the Admiralty chart, I'll create the next video. So I hope you have enjoyed it and learned a lot. See you next time. Bye.